Alright, we are starting a new chapter. This is in chapter 3 of digits. You're on page 45 of your student companion. It's called Perfect Squares, Square Roots, and Equations of the Form x squared equals p. So we're going to do the launch here. Your friend claims that x squared is the same as 2x. Tell how he could have come to that conclusion. Explain whether you agree. So here he's standing here with x squared and 2x, and he's saying they're the same, right? Well, if x equals 2, then they could be the same. What do I mean by that? Well, x squared is equal to x times x, and 2x is equal to 2 times x. So if x equals 2, that would mean this one is 2 times 2. This one is 2 times 2 as well. They both equal 4. Now, this could also be true if x equals 0. But basically, if x equals anything else, it will not be true. So, why don't we try this? Let's try it for x equals 3. X equals 3. So for x squared, since that's x times x, that means it's 3 squared, which means it's 3 times 3, which gives us an answer of 9. Now for 2x, that means it's 2 times 3, which gives us a final answer of 6. So in this case, it is not the same. And we're going to break this down by saying, basically, over here, 2x means 2 times x, whereas x squared means x times x. So they are two different things. This is saying 2 times the same number, and this is saying 2 of the same number. So go ahead and put that under there. In the reflect portion, it says, when have you used the expression with exponents like x squared in mathematics before? Explain. Well, if you remember the area of a square, so area of a square is where you would use an equation like this, where area equals s squared, and s equals the length of a side. Length of a side. Okay, so as always, they gave you a pretty big space for this launch, so we're going to use this space to write some key concepts. So I'm going to put the title right here, Key Concepts. I'm going to write them out. Then I want you to pause me and write them out, and then I'm going to talk about them. Okay, so pause here, go ahead and write all these down, and then unpause. I'm going to talk about them. So the key concepts, the first one is perfect squares, and all that is a number that is a square of an integer, and we saw an example of that in our launch right here. So 9 is a perfect square because it's a number that is the square of an integer, the integer being 3. So squaring just means to multiply the number by itself. Then the square root here is a number split, so that when multiplied by itself, it equals the original number. And I'm going to give you an example over here. So the square root of 9 is going to give us 3. So the square root is 3. 3 is the split number that when multiplied by itself equals 9. I'm going to undo that part because that doesn't make any sense. But so the square root of 9 equals 3. 3 times 3 is 9, which is the perfect square. Now notice these work inversely. They're inverse operations, which just means they undo each other. So we square 3, we get 9. We take the square root of 9 and we get 3. It's just like if we multiply 2 times 3, we get 6. And if we divide 6 by 3, we get 2. So these two are inverses. Same with squares and square roots. Okay, so now flip your page to page 46. At the top you'll see the first got it. It says solve y squared equals 625. I'm going to talk about this box in just a minute. That's not on your paper. So how would we solve this? Well, I'm going to rewrite it because I'll need to show you what we do to these problems. We're solving for y. So basically we're asking ourselves what times itself is going to give us 625. So what we do in this situation is we take the square root of both sides. So this is going to give us y, because the square root of y squared is y. So y equals whatever the square root of 625 is. And you could guess and check and see what two numbers multiplied together gives you 625. But I'm just going to tell you that y in this case equals 25. Now it doesn't only equal positive 25, it also equals negative 25. And you might be asking, why is it both positive and negative? Because also if you multiply negative 25 by itself twice, you're going to get a positive 625, because a negative times a negative is a positive. You're going to see this written many different ways in your homework. So you'll see 25 equal, or you'll see 25 comma negative 25. You'll see plus or minus 25, and that just means positive 25, negative 25. And you'll also see, they'll also want you to answer, these are all y equals. They'll also want you to answer y equals 25 and negative 25. So you'll see it in your homework these three different ways, and they'll ask you put a comma in the middle, or you'll see this plus or minus sign, or they'll ask you to list it like this. So what I want you to do now is write these four equations somewhere in that box and go ahead and try them. What is x squared equals 4? We're solving for x. X squared equals 81, x squared equals 49, and x squared equals 16. Again, let's start you off on this one. You're taking the square root of both sides. So the square root of x squared is x. Square root of 4 is 2, because 2 times 2 equals 4. So why don't you go ahead and pause here to see if you can get the rest of these. Okay, so here are the answers you should have gotten, and I forgot for the first one you needed to write 2 and negative 2, or plus or minus 2, so I did that in the rest of them. Because like I said, why is it this way? Because if we multiply negative 2 times negative 2, it's going to give us a positive 4. This is just like saying negative 2 squared equals 4. So negative 2 squared equals 4 and positive 2 squared equals 4. So you have to write both. X equals 9 or negative 9 for B. X equals 7 or negative 7 for C. And x equals 4 or negative 4 for D. So if you didn't get those right, pause now and write the correct answers. Okay, so now for the second got it. It says solve y squared equals 4 over 9, or 4/9. So again, I'm going to rewrite this one. So y squared equals 4 over 9. And again, you just take the square root of both sides. So I'm going to take the square root of y. Now when I take the square root of a fraction, I'm going to take the square root of the top, and I'm also going to take the square root of the bottom. So I get y equals, and the square root of 4 is 2, because 2 times 2 equals 4. Remember, this is just undoing. Square root of 9 equals 3. Now again with this, it's not only positive 2 over 3, but it's negative 2 over 3, because again, negative 2 over 3 would times negative 2 over 3 would give me a positive 4 over 9. So y is going to equal both 2 over 3 and negative 2 over 3. So now again, they gave you a huge box to do very little work, so why don't you try this example. Go ahead and write it in your book right next to this one. A squared equals 64 over 81. Go ahead and pause me here, try it on your own, and see if you get the answer correct. Okay, so you should have taken the square root of both sides and the top and the bottom of both your fractions, the numerator and the denominator, and you should have gotten a equals 8 over 9 or 8 equals negative 8 over 9. Okay, moving on to page 47, we're going to do the got it. It says a square painting has an area of 460 centimeters squared. What is the length of one side of the painting to the nearest tenth of a centimeter? Well, a couple of things for this problem first. We're not going to have you get the nearest tenth of a centimeter. We're just going to have you tell me which two numbers could be the length of the side. In between which two numbers could be the length of the side. And that'll make more sense in a minute. Now remember we said the area of a square is s squared, or s times s. So all we do here is put in 460 for our area. And what we want to solve for is s squared. So it's going to be the same thing. We're going to take the square root of both sides. And we don't know what this is. This could just be the square root of 460 for now. And we know the square root of s squared is s. So we know whatever the square root of 460 is, that's what s is. And you might be asking yourself, well, the square root of 460 could be a perfect square. It could be an even number. Well, we know it's not, and here's the reason why. All perfect squares end in either 1, 4, 5, 6, 9, or a double zero. This only has one zero. So we know that it's not a perfect square. A number that ends in 2, 3, 7, or 8, or 1, 0, is not a perfect square. So what we want to do is figure out what's the nearest perfect square to this. Well, we know 20 times 20, 20 squared is 400. So I'm going to try 21. What is 21 squared? 21 squared just equals 21 times 21. Which gives us, if we multiply this out, 441. Well, that's a little low, right? We need it to be near 460. Well, this is what I mean. We're going to figure out which two numbers the length of our side could be in between. So let's try 22 squared. 22 squared equals 22 times 22. And that's going to give us, let's see here, 484. Well, that's a little too high. What we want is this 460 right here. But we do know that 460 is between 441 and 484. So we know the length of our side is somewhere in between 21 centimeters and 22 centimeters. So how do we write that? Over here I'm going to give us the answer. It's kind of difficult, but you write it like this. Your variable goes in the center. You have two less. So we put our variable s, this just means side, length of the side, in between two less than signs. This means in between. And what is s in between? S is in between the square root of 441 and the square root of 484, which we now know is s being this length of the side being in between 21 and 22. So somewhere in between 21 and 22 centimeters is the length of one side of our painting. All right, now for the U try. Turn to page 4 or look at page 48. I'm going to have you do number 3. It says a square flower garden has an area of 136 feet squared. Find the length of one of the garden to the nearest tenth of a foot. Instead of tenth of a foot, I want you to find the length. I want you to find the two side lengths that it could be in between. So why don't we use L for our variable, two less than signs. You're filling in these blanks. Which two numbers can those lengths be in between? So pause here, give it a try, and see if you're right. All right, so you should have gotten the length being somewhere between 11 and 12 feet because 11 squared is 121 and 12 squared is 144. 136 falls somewhere right in the middle of that. So your square flower garden has a side length of somewhere between 11 and 12. It could be 11 and a half, could be 11.4, 11.6, something like that. Okay, now for our close and check. And we basically already answered this. Basically, what we want to know from this question is that x squared equals p can be used to solve problems involving squares. Problems involving area of squares. All right, so start your homework 3-1. There should be 15 problems. Thank you.